This poster presents our work in developing a specially disaggregated soil map uh, developed specifically to support digital soil and land valuation assessments in Scotland. National soils coverage in Scotland is available from the National Soil Map at 1 to 250,000 scale, but the major disadvantage of this map is that it is not spatially explicit, in the sense that over 50% of the map's area comprises of complex map units with two or more soil types whose spatial distribution within map units is unknown. So in this context, we use digital soil map techniques to develop a national spatially disaggregated 50-meter raster maps at the soil series level. This flowchart gives a graphical representation of our methodology. The spatial disaggregation of the map units was done at the soil series level. The first step was to randomly draw virtual samples in both single and complex polygons, extract soil series information at the sample locations, and then randomly reassign them based on the assumed cover proportion. The second step was to develop the train dataset by extracting values from selected covariates of climate, terrain, and geology at the sample location. The third step was to train a random forest model at its landscape division of Scotland that we developed in a concept similar to soilscapes in terms of similar geomorphological and soil characteristics. And the fourth step was to generate layers of probabilities of occurrence for each predicted soil series at its 50-meter pixel, and then calculate the first, second, and third most probable soil series at national scale, and assess map accuracies using information from soil profiles. The results of this process showed that the random forest algorithm performed better in areas that were less spatially diverse with a lower coverage of complex polygons. Climatic variables and geology were the most important predictors, and that spatial patterns of the most probable soil series map shown here were quite similar to the ones of the Soil 2 50K map, despite some small differences in proportions of certain soil series present here at a soil type level. Regarding the accuracy assessment, the cumulative matched accuracy for the first three most probable soil series and soil types was 59% and 75% respectively, and most matches for the most probable soils were found in single polygons, while for the second and third most probable soils were found in complex polygons, which kind of indicates that probability layers are useful for exploring the soil spatial variation. We also briefly present an example of how the disaggregated map can be used for land assessments. Here we used the disaggregated soil map to translate it to hydrology of soil type, soil hydrological classes, in order then to select wetland soils, soils that were wet or soils that were peaty or peat. And this was used in order to map the areas that were likely to be wetlands by combining with land cover information in order to be able to then calculate wetland soil habitat type extents and assess their hydrological buffering capacities based on host hydrological indices of low flows and surface runoff. Then this was combined with survey and literature information in order to be able to conduct a qualitative assessment of current and future wetland health related to their hydrological functioning and their capacity to buffer hydrological extremes of high and low flows. The table here presents results of this kind of assessment, and you can find more information in the projects report. So the conclusion of this work was that random forest was effective at predicting complex relations between soil series and environmental covariates. Probability layers are useful for providing an insight on soil variation. Spatial disaggregation implemented at an appropriate taxonomical level can be used to generate harmonized soil property maps by linking with soil databases, and digital soil property maps can be used to build digital land assessment, such as those presented here for mapping wetlands and assessing their hydrological buffering capacity that can be used by land managers for identifying and targeting areas most in need of restoration.